Through the narrow lens of a submarine periscope, a Japanese naval officer was witnessing something that would fundamentally challenge everything Tokyo believed about American industrial capabilities. Takeshi Matsumura held the rank of lieutenant commander, and on that particular day aboard the I-36, he methodically documented what appeared before him in the anchorage. The scene defied logic, at least the logic that had governed Japanese naval planning since before the war began. What spread across the lagoon wasn't merely a collection of warships at anchor. Instead, Matsumura observed what could only be described as a complete industrial complex that somehow floated on the Pacific waters. In the small notebook he kept tucked against his chest, he sketched furiously, knowing these observations would send shockwaves through the command structure back home. His count revealed 6 enormous floating structures, each one dwarfing any dry dock facility that existed anywhere in the Japanese home islands. One of these massive constructions held the battleship Alabama, and the vessel sat completely elevated above the waterline, its hull exposed to the air while hundreds of workers and their equipment moved across its surface like ants on a carcass. Another of these floating facilities somehow accommodated 2 cruisers at the same time. The Americans hadn't just brought their navy to fight in the Pacific theater. They had transported their actual shipyards across thousands of miles of ocean to position them directly in the combat zone. When Matsumura transmitted his coded message that evening, he included words that would echo through Japanese naval headquarters with the weight of doom itself. The enemy repairs their vessels at a pace that exceeds our ability to inflict damage through kamikaze strikes. This situation transcends conventional warfare. The mathematics work against us in ways we cannot overcome. Those floating behemoths that had so disturbed the submarine commander belonged to what the Americans designated as auxiliary floating dry docks, specifically the AFDB series. Each one had been manufactured in sections at different shipbuilding facilities scattered across the United States, then towed across the vast Pacific like pieces of an enormous steel jigsaw puzzle, finally assembled at their operational locations. The second AFDB alone measured 927 feet in length and possessed the capacity to lift 90,000 tons of dead weight. When this facility operated at full capability with its complement of 600 personnel, it functioned as a self-contained industrial plant featuring complete machine shops, foundries for casting metal, electrical repair stations, and storage tanks holding 65,000 gallons of fuel oil. The dock generated all its own electrical power, distilled fresh water from seawater, and maintained operational efficiency that matched major shipyard installations back in the continental United States. What the submarine commander couldn't observe from his limited vantage point would have shattered Japanese naval doctrine even more completely. Distributed across the Pacific theater were 7 major advanced base sectional docks alongside 31 smaller auxiliary floating facilities, effectively transforming every conquered atoll and island into something resembling Pearl Harbor's capabilities. 21 days before Japanese aircraft struck Pearl Harbor, Vice Admiral Osami Nagano had stood in the conference room at the Naval General Staff headquarters in Tokyo, laying out the final operational plans for the coming war. The calculations appeared airtight and mathematically sound. American shipbuilding capacity on the Pacific coast concentrated in 8 major naval facilities. The installation on an island in California could simultaneously accommodate 4 capital ships for major work. Up in Washington state, the Puget Sound Naval Shipyard managed 3 such vessels. Pearl Harbor's installations, positioned closest to where the fighting would occur, might handle perhaps 6 major repair operations concurrently. The arithmetic seemed to favor Japanese strategy. If military operations could damage or destroy 20 American capital ships during the initial 6 months of conflict, conventional wisdom suggested the Americans would require no less than 18 months for repair and replacement work. Damaged ships would need to steam 3,000 miles back to reach Pacific coast facilities. The transit time alone consumed 2 weeks in each direction, effectively removing these vessels from combat availability for months at a stretch. Admiral Isoroku Yamamoto, despite harboring private reservations about initiating war against America, had approved these calculations. Commander Kameto Kuroshima, serving as operations officer, had prepared detailed charts demonstrating American industrial output. The United States had produced 1.5 million tons of merchant shipping during 1941. Japan's production for that same year reached 400,000 tons. But warship construction operated under different constraints, Kuroshima maintained. Naval vessels demanded specialized construction facilities, workers with specific skills, particular materials and components. The actual bottleneck wouldn't be raw industrial horsepower, but rather dock space availability and repair facility capacity. Nobody in that Tokyo conference room had imagined the Americans would simply construct entirely new shipyards and then float those facilities across the ocean to the battle zones. The historical origins of American floating dry dock technology traced back to commercial requirements. During 1927, the United States Navy had commissioned its first self-propelled floating dry dock, designated YFD-2. Unlike permanent dry docks carved from granite and reinforced concrete, floating variants operated on ballast tank principles. Pump the water out and the structure rises. Flood those same tanks and it descends below the surface. A damaged ship could position itself over a submerged dock, which would then lift the vessel entirely clear of the water for maintenance and repair work. By the time 1940 rolled around, naval strategic planners recognized this technology could be dramatically scaled up and made mobile, essentially eliminating geographical constraints from naval warfare operations. The Bureau of Ships initiated what seemed like an impossible program, even by American engineering standards. The goal was to construct floating dry docks large enough to accommodate battleships, manufacture them in transportable sections for ocean transit, and design them to operate independently in remote locations thousands of miles from home. The Advanced Base Sectional Dock Program embodied American industrial organization at its most ambitious. One section would come from Everett Pacific Shipbuilding up in Washington. 2 more sections would be manufactured at Chicago Bridge and Irons, California facility. Additional sections would originate from Mare Island Naval Shipyard. Each individual section weighed 38,500 tons and measured 93 feet long, 165 feet wide, and 75 feet deep. 10 such sections assembled together would create a floating dock with the capacity to lift an Iowa-class battleship completely out of the water. The engineering obstacles appeared insurmountable to conventional thinking. Every section needed sufficient structural strength to withstand Pacific Ocean storm conditions during the towing operation, yet maintain precision tolerances measured in millimeters when welded to neighboring sections at the assembly point. The ballast systems across all sections had to operate in perfect synchronization. These docks required fully equipped machine shops capable of manufacturing any replacement component, from massive propeller shafts to gun barrels. Tamachi Hara commanded the destroyer Shipyard, and he witnessed American repair capabilities firsthand during combat operations near Tulagi in March of 1943. In his memoir written after the war ended, he recalled engaging United States forces and successfully hitting the cruiser Helena with a torpedo strike. Japanese intelligence assessments concluded the damage would require 6 months in a stationary dry dock for proper repairs. 3 weeks later, reconnaissance photographs showed Helena at Tulagi, fully operational and firing her guns at incoming Japanese aircraft. The Japanese couldn't comprehend what they were seeing. Where was the dry dock facility? Aerial observation revealed only empty ocean and small islands with minimal infrastructure. Helena had actually been repaired by ABS-D1, which had been assembled at Espiritu Santo just weeks before the engagement. This mobile facility had lifted the 10,000-ton cruiser completely out of the water, repaired the 20-foot gash torn in her hull, and returned her to active service in 19 days. The identical repair at Japan's Yokosuka Naval Arsenal would have consumed 4 months minimum. Hara's bewilderment reflected a fundamental conceptual gap that plagued Japanese naval planning throughout the war. Japanese doctrine conceived of naval bases as permanent installations with fixed facilities that required decades to construct properly. Yokosuka Naval Arsenal, Japan's premier shipbuilding and repair facility, had been under continuous construction since 1866. The Americans had created equivalent capability in half a year and then floated that capability directly to the front lines of combat. Chester Nimitz understood that floating dry docks fundamentally transformed the mathematical equations of attrition warfare. In a memorandum addressed to Admiral Ernest King and dated January 15, 1943, Nimitz articulated the strategic implications. The presence of floating dry docks in forward deployment areas fundamentally alters force correlation calculations. A damaged vessel repaired in 3 weeks at Ulithi compared to 3 months back in San Francisco represents a fourfold multiplication in available force strength. The Japanese High Command discovered this new operational reality gradually through painful experience. The Battle of Santa Cruz in October 1942 had inflicted severe damage on the carrier Enterprise. Japanese naval intelligence calculated 6 months for proper repairs. Enterprise reappeared in combat operations after merely 30 days, having been repaired at New Caledonia using the destroyer tender Vestal and advanced base facilities. Rear Admiral Matome Ugaki recorded in his personal diary that enemy repair capabilities exceeded intelligence estimates by factors that defied explanation. Ships confirmed as severely damaged returned to battle before Japanese vessels with lighter damage completed their own repairs. By early 1943, the United States Navy operated an entire network of floating repair facilities that had transformed Pacific Ocean operations. Advanced base sectional docks functioned at Espiritu Santo, Ulithi, Leyte Gulf, and Manus. Smaller floating dry docks serviced destroyers and submarines at dozens of scattered locations across the theatre. The construction statistics revealed Japan's hopeless strategic position. Mare Island Naval Shipyard produced multiple ABSD sections while simultaneously constructing new destroyers and cruisers from the keel up. The facility employed 46,000 workers operating 3 shifts around the clock, 24 hours daily. In an 18-month period, Mare Island alone produced more floating dry dock capacity than existed in Japan's entire permanent dry dock infrastructure combined. Haruki Iki served as lieutenant commander and naval architect at Yokosuka Arsenal, and he analyzed American repair capabilities in early 1944. His report calculated that American floating dry docks positioned in the Pacific could simultaneously handle repairs on 18 capital ships, 36 cruisers, and over 100 destroyers. Japan's entire domestic repair capacity could manage 6 capital ships, 12 cruisers, and 40 destroyers at maximum utilization. More critically, Iki identified what he termed the multiplication effect of forward repair positioning. A ship damaged at Leyte Gulf and repaired at nearby Ulithi returned to combat in 1 quarter, the time required for a ship making the long voyage back to Japan. His conclusion carried the weight of strategic doom. The enemy brings his homeland industrial capacity directly to the battlefield. Our ability to sink ships cannot exceed their ability to repair them. The floating dry docks achieved their first spectacular operational demonstration during the Kwajalein invasion in February 1944. The battleship Maryland took kamikaze hits that tore a 40-foot hole in her deck structure. Traditional naval doctrine would have sent her back to Pearl Harbor, removing her from combat availability for months. Instead, Maryland sailed 240 miles to Majuro Atoll, where AFDB-2 waited at anchor. The massive dock facility, commanded by a Commander Joseph Rochefort, who should not be confused with the intelligence officer of the same name who broke Japanese naval codes, submerged its deck structure below the waterline, allowing Maryland to position herself precisely over the keel blocks. In 4 hours, powerful pumping systems expelled 8 million gallons of water, raising the 45,000-ton battleship completely clear of the ocean surface. Yoshitaka Miwa commanded submarine I-184, and he observed this operation while submerged, transmitting to Tokyo that Maryland was entering the floating dock at Majuro with extensive damage visible, estimating minimum 3 months for proper repair. 3 weeks later, Maryland departed Majuro under her own power with full combat capability apparent. The Americans had made time and distance strategically irrelevant. Mochitsura Hashimoto commanded submarine Prax 58 and later wrote about the frustrating pattern that Japanese submariners experienced repeatedly. They would successfully attack an American carrier or battleship, calculate the months that massive damage would require for repair, only to encounter that same ship weeks later operating at full combat capability. Fighting such an enemy felt like battling mythical creatures that could heal their wounds instantaneously. AFDB-7 operated at Leyte Gulf and demonstrated complete overhaul capability when the carrier Franklin arrived after devastating kamikaze damage in March 1945. Franklin had absorbed the most severe damage of any United States carrier to survive the entire war. 807 sailors had perished in the attack. Standard naval procedure would have classified Franklin as a constructive total loss, but the AFDB-7 crew of 1,000 included specialists in every aspect of ship construction and repair. They operated shift schedules that never stopped, working continuously around the clock. Master Chief Petty Officer William Delaney later provided testimony that they essentially rebuilt that ship from the inside out. In a stationary yard with full facilities back home, such work represented a 6-month job at minimum. They completed it in 11 weeks while positioned in an active combat zone. Sadao Kusaka flew reconnaissance missions over American bases as a lieutenant commander, and his April 1944 report revealed the strategic shock Japanese commanders experienced. He had observed Ulithi anchorage in detail and counted 6 large floating structures previously identified in intelligence reports as possible cargo vessels. Upon closer examination during low-level reconnaissance, these were mobile dry docks. One contained the battleship Iowa, with its hull completely exposed for repair work. American maintenance capacity wasn't fixed to home installations, but rather mobile and deployable. They transported their bases wherever combat operations required them. Admiral Soemu Toyoda assumed command of the combined fleet after Yamamoto's death, and he received these reconnaissance reports with mounting desperation. At a staff meeting in May 1944, he presented the mathematics of inevitable defeat. If Americans repair ships 3 times faster than Japanese facilities can manage, Japan must sink 9 ships for every one lost. This represents an impossible operational requirement. The nation was losing to American floating steel and industrial organization rather than superior tactics or warrior spirit. Each dock section included complete living quarters for its assigned crew, featuring bunks, galley facilities, and medical treatment spaces. Robert Leckie served as Seaman First Class, assigned to AFDB-3 at Manus, and he described the surreal daily life experience. Here they existed thousands of miles from home, living on this massive steel structure floating in a tropical lagoon. They enjoyed movie nights projected on the dock walls, played baseball games on the dock floor when no ship occupied the repair bay. They weren't merely repairing damaged ships. They were a floating piece of America itself transplanted to the war zone. The food served aboard floating dry docks became legendary among personnel fortunate enough to rotate through them. While combat ships subsisted on Spam and powdered eggs, the dry docks maintained frozen food lockers and full bakery facilities. AFDB-2 served 2,000 complete turkey dinners for Thanksgiving in 1944 to crews of damaged ships undergoing repair. Takeo Kurita held the rank of Vice Admiral and experienced the strategic impact during the Battle of Leyte Gulf in October 1944. His battle plan assumed damaged American ships would withdraw for lengthy repairs, progressively weakening the invasion force. Instead, damaged vessels sailed short distances to nearby mobile repair facilities and returned to combat within days rather than months. Kurita later wrote about the psychological impact of damaging an American cruiser and assuming it eliminated from operations for weeks, only to face that same ship 3 days later. The Japanese weren't fighting just the American fleet, but their entire industrial system, which they had somehow rendered portable and deployable. The most remarkable repair feat occurred with Yorktown between Coral Sea and Midway. Yorktown arrived at Pearl Harbor severely damaged on May 27, 1942. Admiral Nimitz gave repair crews 72 hours to make her combat capable. The ship entered Dry Dock No. 1 on May 28, and 1,400 workers from Pearl Harbor Naval Shipyard labored continuously around the clock. Yorktown sailed on May 30th with her flight deck patched and boilers operational. Japanese intelligence remained convinced Yorktown was still undergoing repairs. When Japanese pilots reported attacking a third carrier at Midway, Admiral Nagumo's staff couldn't reconcile the report with their intelligence assessments. Joichi Tomonaga reported before his death that the Americans possessed 3 carriers, where calculations indicated only 2 were operationally possible. By mid-1944, American floating dry docks had transformed the Pacific into what could only be described as an American maintenance highway. Ships damaged at Iwo Jima could reach repair facilities at Ulithi in days. Vessels hit near the Philippines steamed to Leyte Gulf or Manus. The enemy had effectively eliminated distance as a strategic factor. Between 1942 and 1945, the United States produced 7 advanced base sectional docks, 31 auxiliary floating docks, and 55 smaller auxiliary repair docks. The combined lifting capacity exceeded Japan's entire permanent dry dock capacity by a factor of 4. Each ABSD cost approximately $40 million to construct and deploy, equivalent to the cost of a light cruiser. Rear Admiral Kizo Kimura captured the psychological impact in his diary entries. The Americans construct floating dry docks the size of city blocks and tow them across the Pacific Ocean as if already certain of victory. They are building the peace while Japan still fights the war. Marcus Thompson worked as Chief Petty Officer and hull repair specialist on AFDB-2, having trained for 18 months at Mare Island before deployment. His team of 40 welders could repair torpedo damage that would challenge major stationary shipyards back home. They became artists of destruction repair, Thompson recalled in post-war interviews. A destroyer arrives with her bow completely blown off. They would fabricate an entire new forward section in 5 days of continuous work. The medical facilities aboard floating dry docks added significant strategic value beyond simple ship repair. Each major dock included a hospital complete with operating rooms and surgical equipment. Lawrence Steinberg served as Chief Medical Officer on AFDB-1 and performed over 200 major surgical procedures during his deployment. In November 1944, submarine I-365 received orders to penetrate Ulithi's defences and attack the floating dry docks rather than targeting warships. The mission reflected changing priorities in Japanese naval strategy. The submarine was detected and destroyed before reaching Ulithi, becoming one of 6 lost attempting to attack floating repair facilities. The only successful Japanese attack occurred on April 22, 1945. Lieutenant Saburo Shimbo and Ensign Chuhei Okubo, flying at 14,000 feet altitude, mistook their target identification and struck what they thought were loaded cargo vessels. A follow-up attack wave damaged Section G of ABSD-2, but the dock's crew completed repairs within 3 days using their own facilities. Masataka Okumiya served as commander and analyzed the strategic failure in post-war writings. Japanese forces could occasionally damage warships, but the floating dry docks seemed to multiply like living organisms. They weren't merely floating docks, but rather floating factories that could effectively reproduce themselves through their complete machine shop capabilities. The Okinawa campaign from April to June 1945 witnessed the most concentrated damage inflicted during the entire Pacific War. Over 400 ships sustained damage from kamikaze attacks. An entire fleet of floating dry docks at Karama-Reto operated continuously, sometimes lifting damaged ships while still under air attack from Japanese aircraft. Toshiyuki Yokoi commanded kamikaze operations as captain, and he recorded the futility of the sacrifice. Japanese pilots gave their lives to damage American ships, only for reconnaissance to reveal those same vessels returning within days. The floating dry docks at Karama Reto repaired ships faster than Japan could organize new attack waves. Of 404 ships damaged at Okinawa, 387 were repaired sufficiently to continue operations without returning to permanent stateside bases. The destroyer Laffy absorbed hits from 6 kamikazes on April 16th and was operational again by May 1st. Minoru Genda reviewed captured American planning documents after the war concluded as captain, and the scope of American intentions staggered him. They had planned to bring 12 major floating dry docks and 40 smaller ones directly to Japanese home waters for the invasion that never occurred. Even if Japanese forces damaged half the invasion fleet daily, the Americans could repair ships faster than Japanese forces could reload their weapons. Working with battle-damaged ships meant handling unexploded ordnance and toxic smoke from fires. On AFDB-3, 7 workers died when a bulkhead collapsed during repairs on the cruiser Pittsburgh. Yet morale remained consistently high among dock crews. The motto of AFDB-2, painted in letters 10 feet high on the structure's side, declared simply that they kept the fleet fighting. Soemu Toyoda's post-war interrogation by American intelligence officers identified 3 decisive factors in Japan's ultimate defeat. American submarine warfare topped the list, followed by fast carrier task forces, and finally the floating dry docks. On that third factor, Toyoda stated that American floating dry docks killed the Japanese Navy as surely as bombs and torpedoes. The Americans made time and distance strategically irrelevant and brought their homeland's industrial power directly to Japanese home waters. Between 1943 and 1945, American floating dry docks performed 1,847 major ship repairs and 8,234 minor repairs. They returned 95% of damaged vessels to active service within 30 days. The intelligence officer Joseph Rochefort, whose code-breaking efforts helped win Midway, offered strategic insight into the floating dock program. The Japanese thought they were fighting ships and men. They were actually fighting America's entire industrial system, which had been rendered portable. Every floating dry dock represented Detroit and Pittsburgh made manifest in steel that could float across oceans. The organizational vision came from officers like Rear Admiral Ben Morrill, who understood that American industrial superiority meant nothing strategically unless projected to the point of conflict. His vision transformed industrial power from a homeland advantage into a deployed weapons system available at the combat front. Mare Island Naval Shipyard employed 6,000 women by 1943. Marjorie Muller worked as one of the first female welders and contributed to ABSD-2's Section F construction. Every perfect weld meant American sailors would survive, she later explained. The Chicago Bridge and Iron Company employed 4,000 African-American workers at its California facility, where they constructed 3 ABSD sections, achieving production rates that exceeded some integrated yards. Arleigh Burke frequently cited floating dry docks as prime examples of American innovation in his post-war writings as admiral. The Japanese brought superior training and tactical excellence to the Pacific War. Americans brought floating dry docks. The Japanese made the ocean a battlefield. Americans made it a factory floor. Japanese naval attachés had filed reports on American shipbuilding throughout the 1930s, but they interpreted observations through their own cultural and industrial experience. Yoshiro Fujimura visited Chicago Bridge and Iron as commander and observed sectional construction techniques. His report noted that Americans built industrial plants like toys in sections to be assembled later. He found it interesting but ultimately irrelevant to naval construction applications. As the war concluded, American floating dry docks were still rolling off production lines. AFDB 8 through 14 were under construction for the invasion operations that never materialized. The story of American floating dry docks represents fundamentally different conceptions of power projection. Japan conceived power in traditional terms centered on warrior skill and tactical excellence. America conceived power in industrial terms focused on production capacity and repair capability. The Pacific War tested these competing visions under the most extreme circumstances imaginable. Once American floating dry docks deployed across the Pacific theater, each one represented the entire American industrial system rendered mobile. They embodied Detroit's assembly lines and Pittsburgh's steel mills transported directly to the battle zone. Against such concentrated industrial might made portable, no amount of traditional military excellence could ultimately prevail. Admiral Toyoda's final assessment captures their ultimate strategic significance. Japan was defeated the moment American floating dry docks arrived in the Pacific. Japanese forces could sink American ships, but the Americans could raise them again. This capability meant the United States could absorb any losses and continue fighting indefinitely. The Pacific Ocean itself had transformed into an American lake, not because the United States controlled every square mile of water, but because American forces could maintain operational control anywhere, anytime. The Japanese finally realized they weren't fighting ships and planes and men, but rather an entire industrial system that had learned to float across oceans and position itself wherever combat operations required it most.